David Smith here with another flipped classroom math lesson. A few tips before we start. First, remember that you can speed up or slow down the playback if that helps you follow along. Second, you can turn the captions on and read my words on the screen. Third, you can pause the video at any time to catch up with your notes or write down questions for class. Today's topic, gradient. Another word for gradient is slope. These two words are used interchangeably, and if you follow along with this video lesson, you'll see that that's exactly what I do. Okay, so here's a line sloping up like this. Here's a line sloping down like that. Gradient is the vertical change divided by the horizontal change. So if I go from 2 points, like A and B, I'm going to have a vertical change, we're going up a little bit, and I'm also having a horizontal change, we're going to the right in this case a little bit. Now, you may already know this if you've bumped into gradient or slope, and you have a more familiar way of expressing that. Do you remember what that is? Rise over run. And if you remember that, then you're going to know how to calculate slope for almost any situation. Okay? So, let's take a look at more closely what that might be. Here's my rise, and there's my run. So if that was some number A, and this was some number B, the gradient here would be A over B. Whatever those two numbers are, and get used to this, slope is often expressed as fractions. And the nice thing is that when you have a fraction, here's your rise, here's your run. Okay, so it's spelled out right there in the fraction. Okay, a couple things to know. This one is going up to the right. This has a positive slope. Now, if we calculated the slope here, if we knew what our A and our B were, it would come out to be a positive number. So any line that slopes up to the right has a positive slope. If your calculation gives you a negative, something went wrong. This one is a negative slope. And this goes down to the right, okay? Okay, now let's calculate a few slopes. We're going to do this graphically. This will burn in the concept of how slope works, and you can always take this approach if the formula is giving you some grief for some reason. On the next board, I'm going to show you the slope formula and how you can calculate it just knowing the points. But first, let's do this on the graph. So here's one. Let me walk you through this one. I've got 2 points. This point here is at 1, 1, and that point there is at 2, 4. So how do we get the rise and the run off the graph? It's pretty straightforward. We make a right triangle by going up and then by going across. And that's a right angle right there. And now we can easily read the rise and the run off the graph. We're starting here, 1, 2, 3. The rise is 3, and the run is just 1. Now when you count these, remember you have to start at 0. I see a lot of times people will count this rise and they'll go 1, 2, 3, 4, and 4 is not right. You're at 0, 1, 2, 3. Okay? So remember, we're rise over run. So in this case, our rise is 3 and our run is 1, so our slope is just 3. Okay? Now, if you feel confident, go ahead and give that one a try. Pause the video, figure out what the rise and run are, write your fraction, and get your slope. Okay, let's see how you did. Again, construct my right triangle. I'm going to go up for my rise, and then across for my run, making a right angle right there. And in this case, my rise is 1, 2, 3, again, like the last one. But now my run's going to be a little bit bigger. 1, 2, 3, 4. Okay, so the run is 4. So now we have rise over run equals 3 over 4. Okay? Okay, let's look at the gradient formula. It's pretty straightforward. For any 2 points, A, which would be x1, y1, and B, which would be x2, y2, the slope is given by this equation, y2 minus y1 over x2 minus x1. And check this out. This is the change in y. Okay, so this is going to get us the rise, and this is the change in x, and that's going to give us the run. So what we know so far about slope fits right in that equation. Okay, let's do a couple gradient calculations. Let me walk you through this one, and then I'm going to turn you loose on that. If you're feeling bold, pause the video right now and do both of these. Okay, so I got my 2 points, A and B. Here's what I like to do just to be sure I'm on the right track with my plug-in step, is mark my x2s and my y2s and my x1s and my y1s. So now my slope is going to be y2, 1, minus y1, which is -4. Keep track of your negatives. Remember, this is in the slope formula. So it comes across. Now we have x2, -1, minus x1, 2. Now we just simplify this. 1 minus -4 is 1 plus 4, so that's 5. And -1 minus 2 is -3. So we write this slightly differently. -5/3. It's the same as 5 over -3, but we like to put the negative in front of the entire fraction. Okay? So this has a negative slope. This line is sloping downward. Okay, pause the video and give that one a try. Okay, so let's see how you did. Here's x1, y1, x2, y2. So y2, that's -4, minus y1, which is 8, over x2, which is 2, minus x1, which is 3. So -4 minus 8 is -12, and 2 minus 3 is -1. Now -12 over -1 is going to resolve out to 12. Okay, let's talk about 2 special situations with line segments, or lines really. Okay, so we're interested in discussing the gradients of horizontal segments. These are segments that are exactly flat, or vertical segments. These are segments that go straight up or down. So think for a minute, and remember, slope is rise over run. What might the slope of a horizontal line segment be? If you came up with 0, you're right. And the reason is, well, let's put this down. It's got a 0 gradient. And the reason comes when you look at rise over run. So for a horizontal line, you have a lot of run, right? Pick any 2 points. You're going to get some number for run. So that would be on the bottom of your fraction, 5 or 20 or whatever that was. How much rise are you going to get? No rise. It's a horizontal line. So the top of this fraction is going to be 0. So 0 divided by something is always 0. So this is why a horizontal line segment has a 0 gradient. Now how about a vertical line segment? The answer to this one's a little different, but the clue is in rise over run. So think about that for a minute. Okay, so what it is undefined. So the gradient here is undefined. And if you think about this word, undefined, you might remember that one of the places it comes up in mathematics is when we try to divide by 0. We can't do that. How many zeros are there in 2? Are there less zeros in 2 than in 20? We can't really answer that question. So instead of doing something with it mathematically, we just say division by 0 is undefined. So with a vertical line segment, your line is going up and down. So you're going to get as much rise as you want. Pick any 2 points on that line segment and you'll get a distance for your rise. But since that line has no tilt, there's no run. So run is going to be 0. So you'll have some number for rise and 0 for run. And that's on the bottom of your fraction. You've got division by 0. You can't do that. So vertical segments have an undefined gradient. Now that you've finished the video, take a moment and jot down some notes or questions for our next class. Remember that you can also watch the video again if you want to increase your understanding. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.